Okay, hello everyone. I would like to talk about the plotting in R today. So the outline is that I'm going to talk about the scatter plot and the blocks plot, bar plot, line plot, histogram and density, how to save the outputs, how to save the figures to be a file, and layouts. And finally, I will talk about how to make the italic fonts and gray symbols in the graph. So in the scatter plot, let's create some data. So I assigned it that as the attitude data. And then I make a new variable called sex, which is a factor, and then I just make the first 15 people to be male and the next 15 people to be female. And ethnicity, uh, I just swap uh, like white, non-white until the end. So how to create a simple scatter plot is to use the plot function. So it is very easy. So plot, and then you put the variable on the y-axis, rating, and then you have the tilde, and you have the x variable complaints. And if you do not put the data set like that and the dollar sign, you just need data equal that over here. Then you see the graph, and yeah, you can alternatively you put plot and then you put that dollar sign and that dollar sign to indicate that we would like to use the variable from a data set. If we would like to provide the labels for the x and the y axis and the title, how could we do that? So it is very easy. So you have the plot function, right? And then you put the x lab means the label of the x-axis, y lab is the label of the y-axis, and main is the title. So you see the label on the x, label on the y, and the title of the graph. So if you would like to provide the regression line on the plot function, you simply use the AB line function. So you put the AB line function and then you just run the regression object by using LM, and then you put the y variable over here regressed by the x variable. Again, you put the data equal that we just created. So you will see the regression line like this. So R is amazing in plotting. So if you compare many packages, R is one of the top. So it provides many features to customize the graph. You can customize the color, customize the point, customize the line color, line type, every single thing that you can think of. For example, if I would like to have different color points are provided for different sex, how could we do that? So we can create a graph that provides no data point at all and just use it as a canvas. So I put everything as previous command, and then I just put type equal n like this. Type equal n mean no data. So you will see a graph without any data, and then we will put the data back later. So next, I would like to provide the blue points for male. So I will use this command. So the main command is points. So I would like to put the point where the x-axis, the x-coordinate is a complaint and y-coordinate is a rating. PCH is the plus symbols, the point symbol. I will talk about that later. CEX is the size of the dot, and then color is blue. So the width function where I attach over here is to temporarily attach variables in a dataset in a workspace. So you will see that I do not use that dollar complaints or that dollar ratings because I use the with function and I attach this dataset to use in the points function. Okay, so I can call complaint directly and I can call rating directly because I use the with function. So because I just select sex equal M, so you will see that I just plot only male points over here with the blue triangle. And for the PCH, the plot symbols, you will see we have a lot of symbols. So 0 is a square, 1 is a circle, 2 is a triangle, and so on. Next, I just provide the red points for female. So I use the same thing. I just change color is red and the data I selected is data $sex equal F means female. Then the red triangle will overlay the graph like this. And we just finish the graph. Okay. Oh, don't forget about the legend. So I make the legend. The position is on the top left. Okay. And I have two elements in the legend, male and female. PCH is the plot symbol, which is 2, which is a triangle. Color is blue and red, and CX is the size of the text and the points. So you will see the legend is on the top left, like this. Instead of using top left, we can use the exact coordinate of the legend. So the left corner will be on the coordinate of 40 and 80 if we specify it like that. And again, CX is the size of text and size of the point. Alternatively, oh, I don't like the red triangle and blue triangle. Why don't I just put the text to represent the points? So I use the plotting function again, the same thing. But in this time, I use text function and the coordinate is complaints on the X, rating on the Y, and label is sex that have male and female. So you will see this graph and it is quite nice as well to me. Alright. So we can customize the axis. So sometimes the text are not in the appropriate place. So we would like to have the finer text or coarser text depending on what we want. And further, I don't want axis to, sometimes the axis do not start at 0, which is maybe it's distort and it's exaggerate the size of the plot and the size of the relationship. So sometimes we want the axis to start at 0. So we would like to change that. I would like to provide additional information such as the position of the mean coordinate. So we can start with a canvas without any axis. So we still use type equal n to not provide any data point, and then we put the axis equal false. So we do not provide any axis, and we put x limit and y limit, which is the starting point of the x-axis and starting point of the y-axis. So it starts at 0 and it ends at 100. For the y limit, again start at 0 and end at 100. You will see this graph. It provide no data point, no axis. So we can set the x-axis and y-axis manually right now. So for the x-axis, axis is 1, so 1 represents the axis on the bottom, which is the x-axis, and axis 2 is the axis on the left, which is the y-axis. So axis 1, I would like to provide the tick at 25, 50, 75, and 100. And furthermore, I use the labels to represent each of the tick where it is, where they are the very low, low, high, and very high. I provide the same thing on the y-axis. So I got this. Okay, I have the axis, but it doesn't have the line go through the origin. So I want to have that. So I use the box function to fill all borders like this. And then the next step is to provide the data point. So I use the text again to put the data point as the text of male and female like this. Already. So right now I would like to put the position of the mean coordinate, the mean coordinate of the data. So I forgot to say, okay, where is my coordinate? So first I need to have mx, right? Mx representing the mean. I am very sorry of the complaint. And my supposed to be the mean of the rating. I'm not sure whether I need to have the S or not. And then I need to put the red dot on the mean coordinate, so I can use point mx representing the mean, the x coordinate that I would like to put the point, and then my, okay, and color is red. Okay, so and then I will get the red dot on the origin, on the mean coordinate, and then right now I have mx and my, right? I would like to use mx and my for the arrow. So this is a starting point. So let's say this one is the mean x and mean y coordinate. Okay, it starts at 0.93 and 1.2 times mean x and mean y. It means somewhere right here. Okay, going to 0.99 mean x and 0.99 times mean x and 1.01 means y. It means it's point to around here. Okay, the code is 2. I will explain it later. The length is the length of the arrowhead, and color is red. So I will clear this screen. Okay, and see again, arrows, the starting point, the end point, and then 2 is that the arrow is on the end point. Okay, so I just provide the command for the red dot, and then I have the arrow like this. I will put the text label. Okay, such that, okay, hey, the point of this arrow is the mean coordinate. So I put the text at the position of 0.93 times mean x, 1.2 times mean y. Position is 2. Color is red, and label is the mean coordinate. You will see something like this. So the position means that, okay, let's this point be 0.93 times means x and 1.2 times mean y. Okay, this is the coordinate, and then if I provide position of 1, it will be on the bottom. Position of 2, it will align at the right, and then like the mean coordinate, then the end would be on the point, and then position of 3, position of 4. Okay, so next, box plot. So if we like to provide a box plot for a single variable, it is very easy, such that we just put the file variable over here, and I also provide the file label as overall rating. You will see this block plot. It is very straightforward. So box plot for a single variable classified by a factor such as sex. So I will use this block plot function. It has a lot of attributes, but let's go through it. So I provide the rating as a variable classified by sex. Data equal that. The x lab is the overall rating. Okay, I put, it's supposed to be y label, right? But I put as a x label because I would like to use horizontal equal to, such that the block plot is on is laying down like this. And box width is the width of the box, and I provide the color, the green one for female and yellow one for male. Okay. The next one is bar plot. So the bar plot for a single variable. Okay, so I has a data set, a frequency of 50, and y limit is from 0 to 60. Color is pink, and x lab is overall rating. It's supposed to be y lab, right? And overall rating should be somewhere like this. So sorry about that. Okay, so bar plot with one factor. First, I would like to find the mean of each sex and the SD of each sex. So I need SD to create the error bar. So the group mean, the means of each sex, provide the height of each bar. So I use the tapply function, and first you put the file variable over here. You put the x variable or a factor in a factor form over here, and then you put the function that you wish. It will provide you the mean of each sex and standard deviation of each sex. So I make the bar plot to show the group means. So just ignore this right now, and bar plot sec m is the mean of each sex, and the y limit is from 0 to 80. Color is pink and sky blue. So you see the bar plot female and male like this, and the bar out, I save it to save the x coordinate of each bar. So this coordinate would be something like 65, and this one is 66, something like that. It will save the coordinates so that I will use it for the error bars over here. So to create the error bar, I use the arrow function, the same thing again, and bar out is the x-axis, the height of each, the x-coordinate of bar out, and 6m plus sd is the top one over here. Okay, we have the x and the y coordinate of the starting point, and then bar out is the x-axis of the bottom one, and 6m minus 6sd, which is the destination of the arrow. Angle is 80, so you see that the arrow is something like this, right? And this one is the angle. Okay, when the angle is 90 degree, is that we have an error bar. Code equal 3 to get this type of arrow, and length is 0.5 is the length of the extension. Okay, the arrow rotates 90 degrees from the line, means that it's similar to error bar. So because the x-axis is not filled, so I use the AV line horizontal equals 0 to fill the x-axis like this. Okay, let's have two factors. So I have sex and ethnicity. So I would like to provide the stacking bar plot or cluster bar plot to represent the data. So first, SEM means sex and ethnicity means. So I use tapply, and this is the y variable, and this one is the factor. We need to combine them by the list function, and then this is a factor 1, and this one is the factor number 2, and the function is the mean. I do the same thing for the SD. Okay, so this one supposed to be the data. So sex on the rows and ethnicity, non-whites and whites on the column. So again, I use the bar graph to represent the cell means. So bar out is the bar plot for SEM, which is the mean of the sex and ethnicity. B side equal true because I want the cluster bar graph. X limit is from 0 to 100, color is pink and sky blue, and legend.text equal true means that I want the legend, and I put all argument of the legend over here. So it's inside the list, and X is the coordinate of the X, coordinate of the Y of the legend, and legend text is male and female. Okay, so there is a legend option, and you will see this. So this is non-white, this is white, and then you see male in pink and female in sky blue, which is kind of weird, but I use it anyway. Okay, so if we use beside equal false, it provides you the stacked bar graph, which is I don't like it, so I just show it. Even though the graph is not completed, I will show it to you anyway, and I don't want to go it further. So go back to the cluster bar graph. We can use the error bar. So bar out is the x coordinate of the cluster bar graph, and SEM plus SESD is the starting point. Bar out is the x coordinate of the destination, and y coordinates of the of the destination is SEM minus the SD. So everything else is the same. Okay, and angle is 90, code is 3 to get double-headed arrows, and length equal 0.2. So you will get the error bar graph, and I would like to fill in the x-axis, so I use AB line h equal 0. So instead of the bar graph, which is I recommended, we can use line graphs to represent cell means of two factors. It's a little more complicated, but it's still nice to have a graph, right? So first, to create a line graph, you need the plot function, and you need to provide it as a canvas. So plot, I just put arbitrary points. Let's say C00 is the coordinate, and type equal n, mean nothing. X is false. X label is text. Y label is overall rating. The title is employee survey. X limit is from 0.5 to 2.5 because I have 1 for male and 2 for female. No, 1 for female and 2 for male if I remember correctly. And Y limit is the range of overall rating. You will get something like this, and then you put the axis inside that. So axis number 1 at 1 and 2, but I use label of female and male to represent 1 and represent 2. Okay, and I fill in the axis number 2 because I do not put any arguments in the axis 2, so it provides the default command and box it to make all borders like this. Okay, first I put the data points for non-whites, so the point, and then SCM, the column 1 of SCM. Remember, SCM is something like non-white, white, and female and male. First I select this column, right, and then I put 1 and 2 as the x coordinate of this data point and this data point. PCH equal 1 because I want the circle, and color is red, so we will get something like this. And the next step, we need the white one, so we select. Oh, okay, so I create the line first, line, and I provide the same data point. LTY is 2 because I want the dash line, and color is red, so you will see the line like this. And then you will see the line type. Over here you can just change LTY to get what you want. And next I put data points and lines for whites, so I select the second column over here, and PCH equal 2 for the triangle, LTY equal 1 for the solid line, and color is blue. We'll get this, and don't forget the legend. So I would like to put the legend on the bottom left, and for non-whites and white, PCH equal 1 and 2, LTY equal 2 and 1, color is red and blue. We will get this. Okay, let's move on to the histogram. Histogram for of a single variable is very easy, so I set the seed, I create the data, and I provide the histogram. Data is created from the T distribution with degree of freedom of 8. Okay, and this is the histogram. If we want to have more bars on the histogram, we can use the break argument to be something more than 15 because the default is around 10 to 15. Okay, we will get this histogram. And if we want the density, first the density is the probability of each data point, speaking loosely. So we need a histogram of the probability, and then we run density x to get the density of a variable. Then we use the line function to have the density line on top of the histogram, like this. Okay. Right now, when we create a graph, it will provide in a window. Okay, it is a separate window from R. And if we would like to have multiple windows of graph, we can use Windows command for Windows operating system, Quartz for Macintosh, and X11 for Linux. So when we run this command, the current window will be inactive but still shown. But a new window is created and it will receive commands from R instead of the old windows. Okay, so saving output. R will Windows in R is one of the device in R. So R have when R create a graph, it need to provide in a device, and Windows is one method of showing a graph, which is one device. Okay, and if we hide def.off mean we would like to turn off the device, then the graphing window will be turned off. It will close. It will be closed. So if you would like to create a figure and save it in a file, we need other types of device to save the output from a graphing commands and then save it later. So we have two types of figures, bitmap image or vector graphic. So the function we use for bitmap image is TIFF, PNG or JPEG, and the vector graphic is PDF. For example, TIFF, we just use TIFF function over here. We put name of the file, the width of the figure and the height of the figure in pixel, and then the point size is the font size of the font inside the graph. We just create this command and then we put the any graph that we want, and then we turn off the device. After we turn it off, x.tiff will be in the current directory, and then we can use that. For the PDF, so we use the PDF command and then the file name, and the width and the height are in inches, and the point size is the font. So you put all graph that you want and then you turn off the device, then you will get the graph. Okay, so for LaTeX user, I recommend you to use PDF because you can import PDF in LaTeX very easily. But for Microsoft Word, in Macintosh, I do not use Macintosh myself, but if you save as PDF, I have searched in the internet and they said that you can import PDF in the Microsoft Word in Apple, but I'm not sure about that. Don't believe in me, just test it by yourself. And for Windows, I currently use it. The first method is to save as a bitmap figures, but you need to use very high pixels, such as let's say 1600 or something like that. Then the graph is more beautiful than a coarser one. But my method is to just save it as PDF and take the snapshot from Adobe PDF, which is you will get a you can just enhance the file size or condense the file size, and then you can take the snapshot of the PDF, which is I can manually manipulate my figure. Okay, The next one is layout. R can show multiple graphs in the same figure. You can just use par command. Par mf row equal to 2 and 2 means that you would like to create 4 figures like this, and when you run the first figure it will show in the top left, and then run figure number 2, figure number 3, and figure number 4. Or you can use mf call. It means that you will fill in column first like this. So I'll show you a very simple example. Par ms row equal to 2 means that the histogram of the normal distribution will be on the first one, histogram of the chi-square will be on the second one, the plot will be on the third one, and bar plot on the fourth one. Okay? Finally, if you would like to have italic fonts or Greek symbols, sometimes we need it. We need in the figure for publication. Initially, I just go to the save the figure, go to the paint program, and then edit by myself, which kind of tedious. But right now, I am smarter. I use the bquote function. So let's create data to run a histogram. Let's say x is a normal distribution from mean of 0 and standard deviation of 1. And use the following example. Histogram x, and then I would like to change the title of the histogram. First is I write main equal in the quote mu equal round mean x comma 2. So it will provide as is like this. Okay, but if I smarter, I use paste mu equal something, and then I put a function over here. Because round is not inside a quote, it will be evaluated, and you will provide mu equal 0.07. Okay, so the next one I use bquote, and bquote you have is something like quote. It is exactly the same thing, but inside the quote, bquote will try to read it as a function. Okay, so mu means that okay, you would like to have the mu Greek symbol, and then you cannot have only one equal sign. You need to have double equal sign to represent an equal sign. Okay, and then you put something like this. So you will get mu equal, but the function is not evaluated. Okay, to evaluate a function, you need the dot and a parenthesis to make it work. Okay, so like this, you have mu equal 0.07, because to evaluate the function you need to put dot, open parentheses, and things to evaluate, and then close the parentheses like this. Okay, if I would like to put an italic font, you just put an italic function like this, and then you will get okay, italic m equal 0.07. Again, put italic function inside bquote to create italic fonts. But things will get complicated if you want to have a long text with some spaces. To have a space, you need to use the bquote. We need to have manually quote the text and link it with the tilde sign. So you need to put a quote over here, and you link the quote with the tilde sign. Okay, histogram of a sample from, and then italic n open the parentheses 0 and 1. So you see something like this. It's not easy, but you need to get familiar with it. Okay, so let's put a text in a histogram. So first, I use the same histogram, and then I would like to put the text that okay, my sample mean equal to some number, and my sample SD equal to some number. You will get something like this. And again, the position of 4 is that you have the specified position -3 and 35 or -3 and 30. And position of 1, position of 2, position of 3, position of 4 should be something like this. Okay, so what I have talked is the functions that are provided. The base are provided, but you can use other packages such as lattice. And the graph I usually use lattice is to have multiple graphs in the same figure, and you classify it by a factor. For example, this one you have 5 gears, 4 gears, and 3 gears. You have 4 cylinder, 6 cylinder, and 8 cylinder for a cars. And then you can make a graph for multiple factors at once, and you don't have any space between the graph, which is kind of nice of lattice. And for the ggplot2 is another package that I will use for the spaghetti plot like this. So you see the chain of individual person like this. Okay, thank you very much, and please leave your questions on the comments of this video, and your question will be very helpful to me and other viewers.